Course 4.
Ma'am, can I just ask one question?
Yeah.
Ma'am, I was referring to this linked list online. I came across they were using some star thing, star and some pointer.
A pointer.
For every linked list, they're using that. I can relate actually. I was looking for some reference stuff.
Yeah. 1 second. I hope you can recollect what we discussed yesterday regarding linked list. In linked list, we will handle data. We will store the data and we will store the address of next data node in a block called as node. So for your understanding, I said node is nothing but we are allocating a memory for node and assume like it's a 7001 memory. In this memory, data will not alone stored along with data, it will store memory address of next data. Am I right? So here it is data, here it is address of next data, some address. So in order to collate this data and address in Java language, we use the concept called as class because class allows heterogeneous collection. Whereas if you take C++ language, node remains node everywhere. In C++, in C language, in order to handle node, particularly in your C language, C is not object-oriented programming. So I want to refer this memory location. In order to refer memory location, we will use the concept called as pointer. And pointer will be denoted with asterisk notation. So since Java is object-oriented, you can use class block. Pointer is not required.
Okay, ma'am.
So in order to refer one node, they might be using something called as node star node or node star start, node star head, something like that. Current node, next node, everything they will use with the help of this notation, which indicates we are not storing a simple data, we are storing some address. In this address, again, we have a data and then one another address, which is referring to a memory, not a value. So we are in course 4. So let's get into the next topic. Please requesting all of you to pay attention. So let's get into one more data structure, which is stack and queue. We are following stack and queue order, but again, we will follow linked list structure only. And it's, as I said, it's the simplest topic. So after linked list data structure, we will use a stack and queue data structure for organizing the data. So Monday, I'll be introducing on tree structure. It's time to think and tell. From a stack of plate, which plate you take out first? When you go for a marriage party, when you are in buffet.
Ma'am, the top one.
Upper one.
So being a guest, you will get into a dining hall and you will pick the first plate. And the person who is standing next to you, he or she will take the second plate. So I am removing the plate or I am taking the plate from the stack of plate from which one is the top. Whereas, so think about the staffs who have arranged this plate, from where they started arrange?
Bottom.
From bottom. So they start, so they will put the first plate, the bottom plate, on top of it they add one more plate. So likewise, they'll add some 10 more plates. All the time when insertions are happening, we will insert. So let's say they noticed that their number of plates has been reduced. So they want to add. Again, they will add on top of the plates. And whenever if you want to remove, again you will remove from the top of the plate. If they want to add some 10 plates over here, they will place it on here, top. If a guest is coming and they want to replace. So these are the collection of plates, how we are storing and how we are retrieving. How can we perform an undo operation on a text editor and other application? So for example, I have written some text as hello world. So after some time, I erased, for example, I erased the world. I started erasing from D, L, R, O, W. So when you do undo, so in which order you will get the data? I typed hello world, then
From
I
last to
deleted.
first. From last to first.
So it starts. I don't know whether I can able to show. 1 second. One second. Please pay attention. So let's assume I typed the word hello world. So after some time, I deleted D, L, R, O, W. Then I realized, no, I want world, hello world. So what we will do? We have the option of
Control Z.
where it will start. Guys, where it is starting? It starts from where you have deleted recently. I started deleting from D, L, R, O, W. So as soon as if I give Control Z, it starts from the letter W. Whichever the letter which has been recently deleted, that got deleted, that got displayed on the screen. See here, I'll show you. So I started with D from the last, but when I give undo, whichever the letter got deleted recently, the last one is displaying first. Back button of the browser. How does the back button of your browser application works? So let's say I started from new tab. Then I went to Stack Overflow, then login, another to Stack Overflow. Now I am in how to ask. When I click back, where it will go? Let's assume we are in how to ask.
Last tab.
The last recently closed tab. From there to here. Again, when you click back button, it will go in the order. If you press back for the 5 times, then it will go to the new tab part. How does the scientific calculator prioritize the symbol used during a calculation? In which order it follows? Yeah. So whenever if you are in the application to do a calculation, yeah, of course, BODMAS rule, bracket will be taken as a first priority, but based on the symbols which you have inserted recently. So 12 plus, so it will do this and it will do whichever the order you have placed. In that order, it starts. The last symbol which you have inserted will be processed based on the priority. Billing at a shopping mall. If there is a long queue at a billing counter of a store in a shopping mall, how the billing is done?
From the first person to the second person.
Yeah, first come, first serve basis. So whomever is standing first on the queue, they will get service first. whomever standing on the who joined in a queue at last, they will get the last service. So here, based on first come, first serve. Whereas if you take here, it is not first come, first serve. So I started with new tab, but this will come at the end. Can you relate? Also here, I started deleting from hello world D, but D will not come first. Whichever the letter got deleted recently, that gets displayed. Same thing, wherever there is a queue concept, same order, first come, first serve basis. Whomever is standing first, they will be sending out, first in, first out. Scanning of baggages at the airport. In which sequence the scanning of baggage will take place? So whenever if you are in a takeaway outlet of pizza, so the system generates token number. In which order the token number will be picked?
First come.
First one. So whomsoever made a bill for the first person will get the first delivery. So likewise, they will prioritize the work based on the token number. I am holding 71. So then they started generating bill from 71 to 72, 73, 74. So I am the one who holding the first token number. I'll be getting the service. So if you noticed in all the example, yeah, pizza shop, where I am, yeah, billing, baggage scanning, delivery of product in pizza, grocery store, online orders. So it will be placed on the order. Based on the order schedule, whomsoever placed by today morning, they will be delivered first. Afternoon will be next. Evening will be the next. How do we manage these structures within an application? So in order to manage first come, first serve, or last come, first serve. So in order to maintain that in Java, we have stack and queue data structures. So queue follows first in, first out. This queue is familiar to all of us. So wherever there is a group of people, we will follow the queue system. So who is standing on the queue for the first, they will be getting the service. First in, first out. I am the one who is standing in the queue. I am in the queue I'm a first person. So I am the first person to get the service. Whereas the stack follows the methodology last in, first out. Can you, okay, let me introduce a hint on this, more introduction on stack and queue. So in this session, we will be discussing stack and its operation. We will implement stack because one and another will have a connection. Queue and its operation, implementing queue by linked list. A data structure that implements the concept of stack. First, what is that? Last in, first out. Stack, please go through all the points. Stack is a collection of data items that can be accessed at only one end. And that end is called as top. So yeah. So you assume that piles of plate or piles of book. So let's assume I am inserting the first book. Let's assume B1. So B1 will be over there. And then I'm inserting B2 and then I'm inserting B3. So if I want to remove the book, what book will be removed first? The last inserted book, which is B3. So if you noticed, the way we are inserting and deleting, storing and retrieving happens at the only one end. and that end is called as top end. Item can be inserted and deleted in a stack only at the top. The last item inserted in a stack is the first one to be deleted. So stack follows the data structure. We go with the term like last in, first out, or the other term is first in, last out. So assume like there is an empty stack. I can add item, I can remove item. The add operation is called as push. The removal operation is called as pop. Push is process of inserting new element on top of stack. Listen carefully. Initially, there were empty stack. Listen. When I insert my first item, one more thing I want to mention on the diagram is the place where I have my first item is called as top element. I have only one element and that item is top element. So when I insert 2, when I am pushing the element 2, I want to insert the new element on top of my existing element, and I will make the new element as my top element. When I insert third element, I need to insert top of my next element. As of now, 2 is the top element. The next element of 2 will be the place where I'm going to insert 3. Then I want to make 3 as my top. Every time you need to add the items next. Why we want to go for this linked list concept next? Why we want to go for, there is a connection between 1 and 2. There is connection between 1 and 2, 2 and 3. Why? Because of dynamic data structure. In dynamic data structure, we will not have contiguous data memory. There will be a random memory. Data will be stored in random order. I will keep track of my elements. So in order to keep track, we are following this data structure. Whenever I am deleting an item, always I'll remove from top. So my 3, the node 3 is the top element. When I go for remove operation, automatically 3 will be deleted. And then now the top will be 2. It will be deleted. And then 1. Can I, okay, 1 second. Let me draw a dragon. So let's assume we have a stack. Initially, the stack is empty. This operation is called as push operation, and this operation is called as pop operation. And this node will be always the place where you are going to insert and remove is called as top. Guys, please come along with me. So let me start from my first process. I want to insert 10, or let's assume 101. So my stack is empty. I should not put top over here. Let me erase it. There is no top. Top is also null. Please come along with me. With this, we will construct an algorithm also. And I would like to revise one another point. So stack follows first in, last out, or last in, first out. Last in, first out, or first in will be the last out. Any real world example you are getting regarding the stack in your home? If you look in and around, can you relate with this? I would like to hear one or two examples.
Yes.
What example? That box. Wait, let me try to. One after another. All right. On the first one, I went to Amazon. Oh my God, I don't want to go to Amazon. So this arrangement is example for stack. I think this will be helpful for me to go ahead with my example. Yeah, so this is example for stack system. One more thing I want to discuss over here. Can I able to remove this third one? No, it's not possible. If I want to remove, I can able to remove only the one which I have inserted at the end. This is also one another thing I want to add along with stack. In stack, I cannot remove or add in the middle of as a middle element. Either to add or either to remove, I can do only in the top position, and this is called as top. When I remove this shuttlecock will be my top. When I remove the first two, this is gonna to act like my top element. Very good example. Any other example?
CD storage.
I want to hear from others.
How do you used to store DVD in a storage box?
Very good example. DVD storage box, DVD box. Earlier we used to have that plastic box. Oh my God. Now there is no concept of CD and DVD. But it's good example. So I used to say, we girls used to wear a bangle. Let's say we started wearing a bangle for a function. Let's say I want to wear some 12 bangles. So in which order I can able to wear it? Think about this stack. Am I making it sense? Can you relate?
Yes, ma'am.
The order of wearing the bangle one by one. Let's assume I wore 12 bangles. So the bangle which I weared at the end is the one I can remove at first. Can I able to insert a new bangle in 5th or 6th position? Not possible. Can I able to remove the bangle in my my 3rd bangle or 5th bangle? That is also not possible. Either if I want to wear a bangle, add a new bangle, or to remove it, there is only one end. This bangle example is one another, and one, what is that? We can say so many real world colloquial example, but everywhere the rules remain same. Shall we start inserting first element? So tell me when I want to insert my first element in a stack. Initially stack is null. I'm going to insert 101, and this 101 node is called as top node. And imagine like this top node is located in a memory address, for example, 1005. And do you have address of next node? Do we have address of next node?
No.
No. So it will be null, and this is my top node. So can we try an algorithm? So if there is an empty stack, what is the first step if I want to insert the first element? Steps. What is the first step?
Check the stack is there.
If I want to insert a new node, step 1 is
allocate memory.
Allocate memory for new node. And second step is you need to assign appropriate value. It can be a single number or it can be an object. Okay. Go through this diagram and tell me what would be the any guesses from this diagram? I'm talking about stack. So I mentioned the term top.
Shifting top to the next one.
Make
Okay. Top next address point was
let's assume we created a new node.
Make top
Make
to new node.
my stack is an empty one. I want to insert first value. When I want to insert first value, any value, I want to allocate the memory. As soon as I allocate the memory, if it is a number, name, or a combination of everything, roll number, name, mark in the form of object, you would put an object. Assign the value. Make top as a new node. Apart from that, top dot next will be null. So which is the place where I'm going to insert another item. So make your current node next is pointing null by mentioning there is no data in my stack element. So let's assume I want to insert 102. What would be the procedure? Let me create a stack. I'll be having stack. Assume like I already have first data. My first data is 101 and it is in the memory address 1005 and I want to insert 102. Assume like 102 is storing in a memory address 1055. What I need to do? Steps please. So very important. So allocate memory and make that as new node. Listen carefully. So whatever the node I have created, 1055 is a new node where I'm gonna to assign my value 102. It's very important. What would be the third step?
Make top as a new node.
Abhilash, you want to give a try? The next 2 point is very important for stack. Only if you have understood that, we can able to proceed with the program. I created 1055 and I have allocated 102. How to establish? There is no relation between 1005 and 1055. It's a random memory. How I can relate?
Linked list.
In stack, how can I relate? I know only 1005 memory holding 101 in my stack. Apart from that, I initialized that node as top node. So how to establish a connection between the current top node 101 and 102? 101 next will be 102. Tell me in technical. What is 101?
Top dot next.
Top dot next.
The new node.
Very good. So I have 101 and I have 102 in different memory. Both are dynamic memory. There is no relation at all. How to establish a relation? So I'll be having 101, which is denoted as top node. So the current top node's next node will be the new node which I have created. And last and very important step is I want to make new node as top, so that my top will be swapped from 101 to 102. I'll repeat the same step so that you will be familiar. 1 second. Let me copy. The remaining, I'm not going to change any steps. And I missed one another thing, which is this one. 101 is pointing to 155 and 155 is holding 102 and it is not having the next value, so make it as null. So assume like I want to insert 1003. Can you help me? What is the first step? I'm not gonna to change any other steps hereafter. The steps remains same. That's all. God, yeah. So I want to insert 1000 and 103. So what I need to do, step 1, allocate a memory. So when I allocate a memory, let's assume 1078 memory has been created, and in that memory I'm creating I'm assigning the value 103. What is the next step? Guys, come on.
Next equal to new node.
Top.next.new node.
That's all. And make
New node as top.
new node as top so that I can shift. So earlier 102 is my top. So top.next is 103. Top.next will be the new node which I have created, which is 103. I am making 103 as top. That's all. This will continue for 104, 105, any number of values in your stack. Always create whenever if you want to do a push operation, insert operation, create a memory and have some value, proper name for that memory which you have allocated for the node. Followed with, already you have made top. Initially top is null. So later I am making top as first value, top as second value. Here I know what is first and second, but think in programmability. So currently my 102 is top. So in order to establish a relation, 102's next will be the new node, so that 102 and 103 will be connected, and make 103 as top, so that if you insert 104, the same will continue. Take time, analyze the algorithm. Whatever the algorithm we discussed, let me create a Java program for the same. Handling top is very important. Yeah. Every time when you are inserting, you need to establish the connection between one earlier top and the new one, and the new one will be the top. Then only I can proceed with next operation. Shall I continue for program?
Yes, ma'am.
Okay, now tell me, I want to remove. Can I remove 101 first, 102 first? No. Always when you remove, it starts removing from 103. So what I need to do to delete, to release my 103 from the stack linked list, it's very simple. So as of now, 103 is my top node.
Top.next equal to null.
Yeah. So what I want to do it is, I want to make top is equal to top.next. What is the next node of 103?
Null.
102.
Previous node.
The previous one.
Top dot previous, no?
Yeah, top dot previous is applicable, but I think I made one point missed. So because it is not doubly linked list, it is in one way. So just for your understanding, I said 101 and 102 will be connected. I think I swapped. It is not like 101 and 102 will be connected. It is like 102 is connected with 101. 1 second, 1 second. I think I missed that. So it is not null. That's a problem. One second, small change, guys. So 101 is not connected with 102. 102 is connected with 101. So that the last will be pointing to null. When I start reading or traversing from the data, it always starts from top node because we know only the top node. So when I try to traverse it, it will start traversing from 103. From 103, where we need to go?
102.
102 and 101. Sorry, there is no discussion on previous. This previous will not come into picture here. We can able to handle only the stop functionality here. I'll make a slight change and we will have a discussion again. I cannot introduce previous. Maybe I have swapped between the relation. Again, I'm repeating. So 101 is holding null for the first time. That is my top node. When I want to insert 102, I'm creating a new node, which is 1055. In 1055, I'm allocating the value 102. And what I want to make is, I think I need to swap my algorithm. 1 second, 1 second. Small change in my algorithm. So I'm just swapping. Sorry. I'll tell you what swapping I did. 102 needs to be related with 101. So what is 102? 102 is new node. All of you agree with me?
Yes, ma'am.
Yes, ma'am.
So 102 is my new node. Its next node will be the top. So that 102 is holding the address of 101. I think I need to swap. Take time, sorry, no problem. Anyway, the last step will not change. The third step only, I think I need to change. Yeah. Again, assign new value, which is my new node. New node will be 103. This new node dot next will be pointing to top. What is the top as of now? The top is 102. So 1003 will be connected with 103 will be connected with 102. For example, 103 will be holding address of 102. 102 will be holding the address of 101. And
Ma'am,
and this is the last value, so I don't have any value, it is null. Now it is, okay, take time. I'll
ma'am,
repeat again. Yes, go ahead with your query.
ma'am, in the third step, 103 dot next will be 102, no, ma'am. Then the top will be 102.
Earlier, the top is pointing to 102. After completing the third step only, I am making 103 as top.
Oh, okay. Can you explain the
Yeah,
third
I'll explain
step?
again. Or we will continue with one another one. Let me use the same algorithm, but I'll draw one another stack. So initially my stack is null. Let's assume I want to insert student record. So I want to insert Ramya record. So tell me, what is the first step?
Allocate memory.
Allocate a memory. When I allocate a memory, imagine like we have 5008 memory has been created. In this memory, I have allocated Ramya. Since I don't have value, I am making this as null. And it's very important. The current node is going to be my top node. The new node which I have created as a top node. So let's insert Prachi. Can you come help me in completing the stack? So initially, guys, please pay attention. So earlier I have 5008 already, and I am having the value Ramya. So I want to insert Prachi. What is the first step? Please follow the step. Allocate a new memory. Imagine like 5050 is allocated, and I am assigning the value Prachi. Now follow the third step. So Prachi is the new node. So what is new node? 5050. Its next will be the top. The top is pointing to 5008. So by the way, I am connecting 5050 node with 5008 with third step. Listen, Prachi is a new node. Prachi's next node will be the previous top. What is the previous top? Which is 5008. And by the way, here it remains null. Please go through third and fourth step. Ensure that is that clear. And what is the fourth step? Whatever the node I have created as of now, make that as top node.
Okay, I repeat it on screen.
Yeah, I'm repeating for the third data. So earlier, when I insert the first record, memory has been allocated, value has been assigned, and the first node will be the top node. Please see, if you have not understood, you trouble me as many number of times. The third and fourth step is important. The order is also very important. So as of now, Ramya is the top node. So when I create a new node, this new node next will be top. By the way, Prachi will be connected to Ramya. Prachi's next will be Ramya. After making the relationship, make the new node which you have created as top node. Earlier, this was top. In fourth step, I am making the new node as created as top. Okay, now again I'll repeat. As of now, which one is top? Prachi node is a top node. Let it be. Assume like I want to insert Vaishnavi record. What is the first step? Same step. So allocate a memory. Imagine like I am taking 5190 memory, and I am assigning the value. And this is a new node. For all your information, this is a new node. What is the third step? And this is new node, by the way. So what I am doing is new nodes next will be top. So new node next will be top. So 5190 is my new node, whose next node will be 5050. Later, what I'm doing in the last step? What is the last step? This is my new node. This new node I am making as top node. So Vaishnavi node will be the top node. So step one and then step 2. This is step 3 and this is step 4. Every time when you are inserting, make the new node as top node. When I want to remove, so go to make your top node to go to the next node. When I want to remove Vaishnavi, you just make your top node marking it to the next one, which is Prachi. When you want to remove Prachi, make the next node to be pointing out to Ramya. Okay, take time, analyze the steps, all the 4 steps. Here, step 1 and 2. Here, step 3. And here it is step 4. We can't do manually, by the way. So we can't say previous. We can say only top.
We also can say na whose previous node is null, that one is topmost, top one.
No, we can't say. No, we can't say. Think.
If previous is null na for everywhere.
No. Where is null? Only in Ramya node it is null. All other are filled with next value is filled with the other node address. Is that okay? Shall we continue the theory to Java program? Can we convert whatever the theory we discussed to Java program?
Yes, ma'am.
Yes, ma'am.